Greetings, friends. My name is John Gabriel, and this is the New Calculus channel. So, in today's video, I'm going to talk about a question that was posed in an old Dutch paper. And the reason I'm bringing it up is due to the fact that I have a young friend in Holland who is going to be taking the final exams, and he initially had some problems with the question. It's not a difficult question, it's just the way it's phrased. And when you take these exams, you have to have a certain mindset. And obviously, the questions are not always phrased in a way to assess your understanding, but to try to trick you as well, which really defeats the purpose of the assessment. I personally would never compose or compile such questions, because a question has to be clear and it has to excuse me, test the competency. So without further ado, let's begin. Let's see the question. So the question is this. It says there is one value of p for which the following holds. Okay, that's what that means in Dutch. There's one value of p for which the following holds. And voor deze waarde van p is de situatie in die figuur geschetst, or geschetst. Forgive my pronunciation, but it's probably geschetst. But in any case, what that means is for this value of p is the situation in the figure outlined. Okay, so the situation is outlined in the figure for this value of p. The Dutch have a way of reversing their sentences. It's the same in Afrikaans. Okay, so they give you this little figure here, which tells you that the function that you're integrating is g, and you're integrating from p to 2p. So if you're not very careful, you might think that p is this distance and 2p is this distance, because I mean, it's one way you could interpret it, right? But it turns out that that's not the case. This p is actually the distance from the origin, and this distance here is 2p. So, and of course that makes more sense because this distance here appears to be twice this length. So a little ambiguity there, not much. And so we're told that this integral evaluates to 0, and we can already say why, because there is positive area above the curve and negative area below the curve, and we know for certain in this case that this area must be equal to this area, right? Because if it's not, then this integral will not evaluate to 0. And of course, this question didn't have to be posed as the integral being equal to 0. It could be equal to any other value, and you would still be able to solve it using the method I'm about to show you now. But in any case, it's a little confusing because it doesn't tell you what g is. So you have to look for a clue. And down here it says, calculate the exact value of p and write your final answer in the form of p is equal to ae, where a is a number. Okay, so what you have to do is figure out what this function g is. Now, the clue is in this little statement here. It's kind of silly doing that, because if you look at this function, without reading any further, it could be any function, right? So, and that's why it pays you, when you take exams, to read the question through carefully and understand it well, because this is really an easy question, but one where you can mess up quite badly. Okay, so let's look at the solution. Well, first of all, since we have the value e here, we might suppose that this is the log of x function. Okay, in other words, and by the way, I've called this g of x g prime of x, and I've called the antecedent function g, but they're basically the same thing if you follow the solution. So, and of course, I'm showing you here on the left what's happening. Let's look at the solution. So g prime x is a derivative, and g is the primitive function, okay? So we need to find for 2p, g of 2p minus g of p to equal to 0, as we saw in the question, right? That's what we're evaluating here. And then, of course, if this function is g prime of x, which is equal to log x, then its primitive is x times log x minus x. It's just the integration of this function to find the definite integral. Well, not the definite integral, but the integral or the primitive function. Okay. So now the definite integral is given by this expression. Okay. Now, so we substitute 2p in place of the x's, right? And we look at this problem here. We know that when you have a logarithm minus another logarithm, it's the same as taking the quotient of the two, and we know that we can place this 2p as an exponent here because it's equal to the same thing. So 2p log 2p is the same as log 2p to the p, right? As you see here. And then, of course, minus 2p plus p gives you p on this, minus p on this side, which gives you p on this side. So, and in the final step, we just take everything to the base e, right? Or we rewrite it in the exponential form, rather. And once we've done that, excuse me, once we've done that, we take the pth root of both sides, and we end up with this. E is equal to 4p squared over p, which means e is equal to 4p, and thus p is equal to 1/4 times e, all right? So we could just let a equal to 1/4. And that's pretty much it. And I've showed you here, and that makes sense because if you look at this function here, the antecedent, the boundary points have the same y-ordinate, and therefore it has to be 0, right? Okay. And so now in the new calculus, area is defined as the product of two arithmetic means. So if you had to take the arithmetic means of all the y-ordinates in this region here, it would be 0. And it doesn't matter what the interval is, because 0 times the interval is 0. And that's pretty much it. I hope you've enjoyed this little video. As usual, I'm not feeling great, so I'll probably not be producing videos for too much longer. But anyway, so that's it. I hope you've learned something if you're a student, and that you'll try to remember these things when you take your exams. I'm John Gabriel. This is the New Calculus channel. Until next time, goodbye.